Hello everybody. So have a good day. Let me introduce first because you require my introduction again because maybe either you will be scared or you will be shocked to know that I am the same person whom you have seen that videos in last few weeks and which was taken in 2004 and now it is 2017, that is more than 12 years, and as you can see that many things happened and I have become older, my hairs disappeared. Considering all those aspects, I thought, because I have got many mails from different students, professional engineers, I have got it, and then I found that everybody interested to know that after this lecture which we have done piecewise, that how can we make it combine, and for that we have decided today to give the lecture on design of reinforced concrete structures, design of multi-storied building frame. I have chosen this particular one, multi-storied building frame. So there are few questions are there, and let me tell you what we are going to do. First of all, the design of multi-story building frame. Before going ahead, let us recapitulate whatever we have discussed in last almost say 11 weeks, and then we can find out and we shall discuss that one, that reinforced concrete elements. Let us recapitulate. There are many more things are there, we shall discuss that one. Design of G plus 3 story school building, that we shall take. Then plane frame analysis, that is the major one you can find out. Design of beams, that I have taken example because we shall not be cover up whole thing. Considering that aspect, let us come back to that design of reinforced concrete elements. We are following the code of IS 456. And as you all know that we are having axial force, flexure, shear and torsion. So any member can have either one of them or all of them. How do I say that one of them or all of them? Whenever we talk that one from engineering point of view, we talk which one is the governing one. Let us discuss this one first half an hour and then we shall come to that problem. We have done these beams, singly reinforced section, doubly reinforced section, plain section, excuse me, there is a C missing, plain section, shear, we have. Then for slabs, one-way slab, two-way slab, columns, short columns, long columns, then footings, staircases, and we shall have torsion and deflection check also. So these are the different things that our IS 456. Now let us come back to that code we are following, that is IS 456, and which we are following that one 2000. So last revision was 2000. We have discussed on working stress method. And then we have discussed on limit state method, and there are two aspects. One is that limit state of collapse, and number two, limit state of serviceability. Considering this, we have designed that beams, and as we all know, rectangular, section then we have T section, I mean to say flange section, and we have inverted L. So, reinforcement we are providing here at the bottom, let us provide here, I do not have sufficient space, let us provide only 2. So, coming to this one here, that whatever we are talking, that what is the basic difference between that? Working stress method, it gives limit to the stress. Limit state method, it gives limit to the strain. So, here let me write down epsilon c 0.0035, epsilon s, please mind already you know the 0.005 for any grade of concrete, epsilon s, that is here 0.002 plus 0.87 Fy by Es. Es is the modulus of elasticity of steel. This is the one, let me write down so that way. So, Es 2 into 10 to the power 5 Newton per square millimeter, that is for any grade of steel. So, from there we can find out the neutral axis, that we can find out here. We are not going to detail of all those things here. The question is coming here, how shall we apply these elements in any structure? There are 2 type of structures mainly you can consider where we can use it, though reinforced concrete actually having many more application, but only thing I could say that one is the building. Now, whenever we are talking building, the building we are having, that can be say residential, then administrative, educational, I mean to say this is office, educational building. So, like that we can have that. Coming to this one, whenever you are having this type of buildings, you can see that the dimension of this type of utilities having almost fixed, it do not move actually, it does not move too much. Say for example, residential building if you consider, so generally it comes, say generally still we use that one, just that is why I am telling, say 10 feet we are considering, which is equivalent to, you can say 3 meter, 12 feet 3.6 meter, 14 feet 4.2 meter. So, the range comes then 8 feet, write down, because in washroom other places you can find out that 2.4 meter, you can go 2 meter, and you will find out in residential building, you will find out the dimension you are getting something say 2.4 meter into 3 meter for washrooms. So, like that. Then bedroom, generally it comes something in the range of say 10 feet by 12 feet, that way also it come common. So, that way you can say 3 meter into 3.6 meter, or say 3 meter into 4.2 meter, or something in between 3.6 meter into 4.2 meter. So, these are the different kind of dimension we come across whenever we use a residential building. The drawing room you will find out, which may be in the range of say 4.5 meter, maybe say 6 meter, too big, it is very difficult to get nowadays. But anyway, so these are the range we get it actually that your building. Now, that what is the next question? Next question here, where shall we place columns and where shall we place beams? Administrative office, if we consider, there you will find out here almost say 7 meter to 10 meter one side, the other side you can find out, but that this clear space you require. Educational one you can find out in the range of say 5 meter to 8 meter. This is the one I mean to say, this is the requirement that between two columns you require this much of gap. That is the idea, that particular one we should know and we should use it. Coming to that one here, let us take one. The next question is coming first. Your placement of beams and columns. We should have certain kind of rule. Our objective that beam placement, it will be dependent on the size of slab. So, this is one important governing factor, that slab, it will, because we want something nowadays we give something in the range of say most of the cases we give say 120 millimeter thickness of slab. Earlier we used to give 100 millimeter, nowadays we give 125 millimeter because it is dependent on the span by depth ratio. As you know that span by depth ratio, we can tell already you all know. So, cantilever beam, this is the basic values, span by depth 7, simply supported beam this is 20, then continuous beam or slab, this is true for beam and slab also, for all of them. So, this one 26, these are the basic values. And these are modified with different kind of say steel and other aspect which you can find out in IS 456, that you can find out. This is very, very important aspect in design. Your basic rule that before you start, we shall come back to analysis, then we shall discuss that one. Whenever we discuss this particular one, because this one will give you that basic dimension, initial dimension of that, and that is very, very important here, that your span by depth ratio. Sometimes we get span by depth ratio that may be less also, that way we can find out, and on the basis of that we can decide. So, question here that 125 millimeter is the thickness, let us say we shall provide, that is the one we shall provide, and most of the cases you will find out that we provide that only. Generally just for though it is out of the context because we are talking only for buildings, but anyway just let me tell you for bridges, that is the bridge deck, the top portion actually you are having the bridge deck, I mean to say like this you are having, just to give you idea, so that say like this, and this is called deck and this is beam. Generally this thickness here, as I have told you 125 millimeter for the residential building, most of the cases we generally do not go more than 115 millimeter. Then here it generally comes something in the range of say 225 millimeter, 225 millimeter to say 250 millimeter. This is the one for bridges. So, this is the one we provide that just to inform you that these are the things we follow. Now, question is that 125 mm, whenever we are talking that we shall not give more than that, then how shall we restrict that we should not be more, because it is dependent on the span. Since it is dependent on the span, so here what will happen, that if we think that we are increasing the span, so we shall stop there when that span will give you that more actually your that slab depth. So, that we shall stop. So, that means here whenever we are having any panel and this panel, let us say Lx and Ly, so as you all know that Ly by Lx, not for simply supported, for continuous case, it will be 1 to 2. That means, if it is more than 2, then it will act as a one way slab. That means, here whatever you will get, that we used to get that one, say your Mx and My. So, this Mx, whatever we say alpha x W L square x, alpha y W L square x, this is the value we get it here. That means, here you will find out if Ly Lx it is increased, then you can find out that this value is coming, My value is coming very less. You can try that one for simply supported slab. There is one simply supported slab which you can immediately you can derive on your own, and on the basis of that you can find out increase Ly by Lx, and then you will find out that value is coming very less. And simply supported case, very interesting thing, you will find out that you will get that one here, say W L square x by 8, that means here 0.125 W L square x. This value 0.125, whenever we are getting that value here, that particular one you can, that is the maximum we can get. For simply supported case, you can see the code and you can find out the value you are getting, the same value you are getting it here. Just I shall tell you that particular one here, so it will be easier for you to find out. Yes. So, just you refer table 27. So, refer table 27. So, refer table 27 of IS 456, and for 3 that value is coming alpha x, this is for simply supported one, and which is written here 0.124. The value which is written here, just to give you this particular one, you please see that particular, this is 0.124. That means, here we are getting 0.125, here it is, that means it is up to at 3, at Ly by Lx equal to 3. This is the value we are getting here, Ly by Lx equal to 3, and for that case we get 0.124. That means, if the Ly is more, then this value will come to 0.125, which is nothing but W L square x by 8. So, that means, here the other value whatever you are having, that particular one, just to show that alpha y 0.014. So, this value again will come down, and then, so that means this particular moment will be very low. Whatever section that is provided, that will be good enough to take care that moment. The moment of resistance of the section itself will take care that. That is the basic idea. Coming to this one here, so when that be the case, so obviously that we can find out that how much will be the length of that Lx, because Ly we can make it here, that particular we can have that beam and that or column at certain spacing we can make it here. So, on the basis of that we shall decide the value of Lx. So, if the Lx goes to certain threshold value, then since slab depth will increase, then what we shall do, we shall give that one, make a, either it can be in that, divide it here itself. So, if we divide here itself, that means your span will be reduced and then your slab depth will be within that limit of 125 millimeter. So, this way we can, that means the beam will take care that your thickness of the slab, that we can make it here. The next question is coming, how shall we provide the your column, where shall we provide the column? What we do generally, that column we provide at beam junctions. So, then our guideline here, that we can say, number 1, beam spacing is dependent on slab thickness. There is a, we never go beyond certain value. Number 2, columns are generally, why I am telling generally, because not always we provide that. So, I am coming back, columns are generally provided at beam junctions. So, this is the one we provide. So, this one will help us to know why I am telling generally, because it may happen that you are having that particular one, you are very close, then we can provide the column here, but this spacing is so less, then this only beam provided. So, that means from here the load will go here through this beam, that is the idea of that. Now, next question is coming, why I require this beam? This one generally we require to support, beams are provided to support walls. Whatever we can do, that this particular wall, generally 125 millimeter wall we can provide directly, but sometimes we provide that, below that we can provide one beam. But since this particular one, and if we provide that column here, it will be very close, to avoid that we provide that. So, that is why I have told that not always we provide at column beam junctions. So, it also depends on that, wherever we are having that your say sufficient space is there, because we have to provide footings also. So, we have to provide footings also. So, because of that, so because if we have that one, then it will be combined footing, other problem will come. Our main idea that one, say at least minimum say 3 meter gap should be there between columns, more also. So, considering all aspect, this is the things, on the basis of that we shall decide. Now, coming to that one here, we shall say, so I have told singly reinforced section, doubly reinforced section we have discussed, plain section, doubly reinforced section we provide, where we provide, generally we provide that support, and also to reduce the depth, where there is a depth restriction, that we can find out here. Regarding one way slab, two way slab we have discussed, just let us consider about columns. Columns that we provide, there is one important aspect in columns. Let us say this is depth, let us say this is depth and this is B, that width. Now, there are two axes. What we can do, x and y. You will find out it is written something say Lex by D and Ley by B, mainly IS 456, SP 16, you will find out that. This one means that moment, just this is the convention, always moment actually about, but in this case we mean to say that moment along axis. In this case moment along axis, that particular one, that actually the moment whatever we are having, that moment that is actually about y, but you are representing that one to comply with this d, so that one can understand that moment is this way, and then this d will be required, because this moment that is required, this d, and this moment that is actually registered by B. So, but the thing is that this one we particularly IS 456 and your SP 16, they provide that along. The other one is moment about axis. So, that means same moment, this one if you say Lex other things, that particular one we consider that particular one by D, that means you are considering along this one. But if we consider this way, that Lex by B or Ley by D, that means we are considering this is about. So, which particular one you are considering, that also you should know, because in analysis we consider about, and this one the convention they follow, though actually they are using about only, but the convention they follow that only that to mention that one along. So, this is the one as per IS 456 or SP 16. So, you can consider that. Now, what we shall do it? So, these are the things just to give you idea that basic philosophy we have to choose. On the basis of that we shall decide that particular problem we shall consider, and then we shall take one actually just residential, not residential, school building we shall consider, and then we shall go step by step how we can actually, where we have to address, how to analyze, and which beam we have to consider, how to design, and how many beams we shall design, how many types of beam we shall design, how many type of columns we shall design, that also we shall discuss that in the next module. So, we are taking this module as an half an hour module. So, next module we shall consider our thing, and then footing, that part let us just discuss that one. Footing, that one will be dependent on the shape, bearing capacity of soil. So, we have gone through that all the components, but we have gone through all the components, beam, slab, then footing, then staircase also, that also we have considered. The design and your analysis will be to depend that during construction you will find out that we go from the bottom up, and then in design we come from up down, top down, or you can say from the top you can do, that means say roof, from the roof you have to go other floors, and that way we have to find out. So, we also know how to check for torsion, how to check for deflection, and all the things as we have rightly pointed out that we all know how that individually, that means if you give the bending moment, if you give the moment, that is fine, but how shall we get those values, that is very very. So, at this stage it may not be clear how to apply these design methods to a full structure, and that we shall discuss, and that we shall talk in the next module. Thank you very much.